Okay, I'm going to kind of work through this test review, solving each of these problems. This way, if you have questions, you can look at it. If I do not see you before your final, or we do not have time to go over it before your final, this will be kind of a good resource for you. So the first two problems is asking you to say the solution to each of the systems. So when you're looking for a solution to the systems and its graph for you, you're looking for the point of where they intersect. So right here is where they're intersecting. So we're looking for our x and our y value. So we have 2, -1. Same thing for number 2. Again, you're looking for where do they intersect. So you have your x and your y, so 3, 4. Lastly, for 3, if they're parallel lines, okay, as these two are, you're not going to have a solution because they're never going to jump each other. For 4, the height of a golf ball in meters when it is hit is modeled by that equation, where x is the time in seconds. How long is the ball in the air? Okay. So when doing this, we're going to use our calculator. So with this, we're going to want to go to a graph, and we're going to graph the equation that's given. So -5x squared plus 40x. It's going to graph it. Now, what this is saying is this x-axis, this is the ground. Okay, so they go to the ball, it goes up, it finally comes back down, and when it hits the ground, that's how long it was in the air for. So we're trying to find our 0. So with that, we can go to Control T for our table, and we can move down to where our y value is back to 0, which is at x equals 8. So that's showing us that it's in the air for 8 seconds. Okay, number 5. So for number 5, it's asking this solution for systems of equations. Now, if they give you a table, you need to be able to identify it in a table. If they just give you these two equations, we can use our calculator trick, which we know. So we go just straight to a calculator. We can go to menu 3, 2, so solving systems of equations. We have 2 equations, so we're going to keep it as 2. And we're going to go and we're going to type in our equations exactly as we see it. So y equals sign x minus 5. And our second equation is y equals sign -2x plus 4. Oops. And we get that our solution is 3, -2. Now, to show it how they're wanting to see it in a table, we can go to our actual graph. And we can graph first, our first equation here. So y equals x minus 5. So it's already y equals, so we're going to type in x minus 5. And we're going to go to our table. So go to this point. So the target was 0, so 0, -5. 1, -4, 2, -3, 3, -2, and 4, -1. Now, we want also our second, so we're going to go Control I again to our graph, and we're going to type in our second equation, which is -2x plus 4. Again, go to a table and fill in our table that we have. So when x is 0, y is 4. At 1, it's 2. At 2, it's 0. At 3, it's -2. And at 4, it's -4. So whenever you're looking at a table, and you're looking to see what your solution is, you're looking for at what x value is your y value for both of those equations the exact same. Well, right here, the x value is 3, and both of those y values for both of those equations is -2. So, in which row row 4 tells us, and that tells us our solution is 3, -2. So this was proven right, so either way works, just to kind of depend on how they give it to you on a final. Now, 7, 8, and 9, okay, all of these can be solved by just using your calculator. So going to menu, 3, 2. Now, we have to remember that we cannot put p into our calculator. So instead of p, we're always just going to replace whatever variable with x, if it's not already. So we go to our calculator, and we go back to just our calculator itself. I'm going to go to the okay. So we go back to our calculator. We can go menu 3, 2. Now again, there's only one equation now, so we're going to change this 2 to a 1. And we're going to input on our equation. So 14 equals sign, negative parentheses, x minus 8. So exactly as it looks, but instead of that p, changing that x. And we get that x equals -6. So we know that our variable, so p equals -6. Okay, we can do the same thing for number 8. So again, menu 3, 2, solving systems. Again, we only have one equation, so we're going to delete that equal sign and put 1. And we're going to go through and we're going to input our equation. So 2 parentheses, 4x minus 3 minus 8 equal sign 4 plus 2x. And we get that x is equal to 3. Okay, lastly for number 9, the exact same process. Oops. So menu 3, 2. Again, we only have one equation, so we change that 2 to 1. We're going to input it exactly as you see it. So we have to input the fraction as it is. So we push control divide to give us that fraction. We type in 2x minus 1. On the bottom, we type in 3. We're going to go over to the side of that fraction and put our rest of our equation. So plus 5 equals sign 2. And we get that x is equal to -4. Okay, very simple. Use your calculator. Okay. Now, for 10, so Jason has 18 coins in his pocket, valued at $1.60. He only had nickels and dimes, which would be the system of equations that could be used to solve for the number of each type of coin. So we had a total of 18 coins, and that's including his 9 nickels and dimes. So our nickels and dimes are going to equal that 18 coins. So we know that B and C can be our answer. Okay, now we're going to go. This would be 160. And now we're going to go and we're going to say, okay, well, a nickel equals 5 cents, and a dime equals 10 cents. Oh. 1 cent. Okay. So then we look in which one of those has those values. Well, A has those values. For 11, suppose that you bought supplies for a party. 3 rolls of streamers and 15 party hats cost $30. Later, you bought 2 rolls of streamers and 4 party hats for $11. How much each roll of streamers cost? How much did the party hat cost? So 3 rolls of streamers. So we're going to use, they're using S and H. Okay. So 3 rows of streamers, and so I'm adding 15 hats is going to cost or equal $30. So one of my equations needs to have this. So I'm going to go through and I'm going to see which of these not. I see it right here. I don't see it in B, so that can't be it. It is C, 3S, 15H. Nope, not equal to 30, so that can't be it. And 3S plus 50. Nope. So my answer is in A. Okay. Next page. Solve which of the following system of linear inequalities graphs contains the point 8, -3 as a solution. So as a solution means it's going to be in the dark area. So that is this area, this small little area, and that doesn't even really matter. Okay, so we're going to look, where would 8, -3 be? Well, 8, -3 is going to be somewhere probably over here. Okay, the only one that is included is in B. So 13 through 16, with this, depends on how you want to go about it. Okay, for some people, they do better when there's answer choices and there's no graph and match, which is awesome. Okay. Now remember, I'm going to show you both ways. Okay, and I'll go through and show you mathematically, and then I'll show you graphing and matching. Okay, so when looking through this, so mathematically, okay, so we do a to the third, and we're multiplying, which means we're going to add the exponent over here, which will just be a 1. -3 plus 1 gives us a to the -2. Now, one of our rules is that we cannot have a negative exponent. So what we do is we just move it to the bottom of a fraction. So at the bottom of a fraction, we have a squared, which turns out positive. So if we don't have anything on top, there's just that 1. Okay, now that's how you would do this mathematically. Now, if there were answer choices, such as a squared, b 1 over a squared. Okay, so what we can do, so I'm just going to put 2. Okay, so in your calculator, you would be able to go to a graph. So if we type in our original, so a, or we can't put a, but we're going to put x, so x to the -3rd, we're going to multiply it times x to the 1st. And it's going to graph it. It might look a little crazy, it's okay. Okay, so now we're going to go and we're going to push tab to be able to graph something else, and we're going to type in x squared. Is that the same line? No, so I can get my answer. Okay, then I would go to B and push tab again. Now, you can just go into your next one, you can go up and delete this one, and be able to just type in your next one. So in a fraction, I'm going to type in 1 over x to the second power. It's the exact same line. So those graph and they match, so that's my answer. Okay. So how that would work for 13 and 15 are going to be the same. Okay, and you've got to match that same way. Now for 14, mathematically, okay, this 3 is going to distribute to every exponent. So what that means is I have 8. It was the first exponent, and it's going to be multiplied by 3. X to the second exponent is going to be multiplied by 3. And y is to the second exponent, and it's also going to be multiplied by 3. So what I do that, I get 8 to the 3rd power, which when I put that in the calculator, you get 512. I have x, 2 times 3 is 6, and I have y, 2 times 3 is 6. So that would be my answer. Now, if we want to graph and match, okay, so let's say we just have our original. Let's say we have A is 24, x is 6, and y is 6, and B is 512, x is 6, y is 6. Okay, now, if you're graphing and matching more than one of your exponents, you cannot do that in a calculator, but we've beaten the system, okay? And what we're going to do is in our actual equation, the original is given, we're going to take away the y, as if it's not there. So we take it away in our original, we're going to go to our answer choices. Here we're also just going to take it away. So, now when we graph it, we're going to graph it still in the parentheses exactly as it is. So 8x squared and to the power of 3. And then we're going to go to our answer choices and we're going to tab and we're going to say, okay, 24x to the 6. Oops. We're going to say, they look similar, but they are not actually the same. Okay, you can look at it and you can tell the two opposite lines. So, if you're not exactly sure, if you go to your table, you can tell that those y values, those are different. Okay, now we're going to go back. So we're going to get out of that table, and we're going to push tab again, and we're going to go back up, and we're going to delete what we just put. And now we're going to type in b, and we're going to say, okay, 512 x to the power of 6. I'm going to push enter, and it looks like the same line. Again, I can check myself. I can go back to my table, and those values for my y values are exactly the same. So I know that's the exact same line. So I know then that my answer would have been A by graphing and matching. Both will work. Okay? That's the same concept that you would use for 16 when graphing and matching. Okay? Now, if we look at 15, mathematically, we're looking, where is the large number? The large number is on top. So we're going to say on the top, what is r to the 33rd minus 17? Well, when I do that math, I get that r to the 16th is my answer. Again, if you wanted to graph and match, you would graph it the same that you would 13. Now for 16 mathematically, I look at my a's, okay? Where is my larger exponent? Well, my larger exponent is on top. So I would do a 6 minus 2 up top. Now then my b is, where's my higher exponent? On top, so I keep my b on top too. So b, 4 minus 1 from the bottom. Now I look at my c's. I have c and c2. My larger exponent for this is now on the bottom. So I would have c2 minus 1. So now I would go and I would say, okay, well, a, 6 minus 2 is 4. B, 4 minus 1 is 3. And C, 2 minus 1 is just C. So that would be my answer. Now, again, if we wanted to graph and match, just as if we did for, we do it just like we did for 14, so we have to get rid of variables. Now, this one has 3 variables, we can only keep 1, so now instead of eliminating 1, we're going to eliminate 2. And in our answer choice, we would also eliminate the 2, and be able to see which is the same. Okay? Moving on, 17, so we would 12x squared times 13x squared by 9, because we're looking for area, and we know that area is length times width. Okay, now again, if we wanted to graph and match, it's the perfect opportunity to do it as well. If we wanted, well, we're not going to graph and match yet. We're going to actually work it out. So we did this. I'm going to write my numbers by each other. So 12 times 13. Then I write my x's by each other. Then I write my y. So I have 12 times 13, which is 156. X squared times x squared is x to the 4th. And y to the 9, which is y to the 9. That would be my answer. Okay. If I wanted to graph and match, I could do that. It would be the same process. So if I wanted to do that, I could graph. I have to take away my y. Okay, but let's say my answer choices were A, B, so 156 x to the 4th, y to the 9th, and 156 x to y to the 9th. Okay, again, I have to take away the y here, and I take away the y here, and I will just graph and match. Now, the only thing I really need to do then for this is to be able to get it into the form. Now, for 18, knowing volume. So volume is length times width times height. Since they're all multiplied together, it doesn't matter what comes first, what you start with. So if I start with 8, then 3x squared y, and then 2x y to the 5th z. Again, you can solve mathematically, or you could graph it mathematically staying the way that you did up here. If we did mathematically, combining them, so 8 times 3 times 2, x2, x, y, y5, and z. So 8 times 3 times 2 is going to give me 48. X squared times x gives me x cubed. Y times y to the 5th gives me y to the 6th. And I still just have a z. So then there's my answer. Okay. 19. So knowing that exponential is y equals a times b to the x power. Okay, now they give us a population. So the starting population is going to be our starting value, which is a. Now, if they give us a percentage, we have to take 2.5% and we have to convert it to a decimal. Okay, so all I'm going to do is I'm going to move this decimal point over twice. So my new decimal is 0.025. Now, because it's increasing, we're going to add 1 to that. So we have 1.025. Okay, now with that, that's going to be my b value. So when I write my equation, I have y equals 450,000 times 1.025 to the x power. Now, they want to know after 6 years. So I would plug 6 in for my x value, put it in the calculator, solve, and when I do that, so use a normal calculator. So 450,000 parentheses 1.025 to the 6th power. I get 521,862. Okay. Same thing for 20, but now it's decreasing. So I take my percentage and move it to a decimal, so 0.12. I now subtract because I'm decreasing. So I have 0.88, and I plug it in. So y equals 25,000 times your b to the x power. Okay, 21. So with this, all you really need to know is linear, we're going to be adding or subtracting. Quadratic, up and then down, or down and up, and I'll explain that in a second. And then exponential is multiplying or dividing. Okay. Now, I think that, or how I start off, is I look and say, can I add or subtract first? Because that's really the easiest to find out. So if I do 800 to 1200, I would be adding 400. Now, if I add 400 to 1200 though, it doesn't give me 1800. So I know I'm not adding. So now I'm going to say, okay, am I multiplying? Am I dividing? What's happening? Okay. When I put this in my calculator, I see that I'm multiplying by 3/2 every single time. So that's going to be exponential. Now, if it's exponential, now we're looking, is it a growth or a decay? All you're looking after that is as you go down your table, are the numbers increasing or decreasing? Well, if we go down, those numbers are increasing, so it's going to be exponential growth. Okay, so 22, I look. I say, okay, to get from 2 to 4, I add 2. Okay, if I add 2 to 4, do I get 6? Yes. Okay, so on this one, I'm adding 2 every time. So because I'm adding, it's going to be linear. Okay, same thing if I look at 23. To get from 2 to 5, I add 3. If I add 3 to 5, I get 8, which is what we want. So I'm adding 3 every time, which also is linear. Now 24 is some big numbers. I think you might even just try out with this one, trying to figure out maybe put in your calculator. Okay, and so figure out, are you dividing, are you multiplying, what are you doing? When you do that, you see that you're dividing by 4. That's going to be exponential. Okay, as we move down our y values, are they increasing or decreasing? They're decreasing, so it's an exponential decay. This is what I'm talking about up and down. So if we go from 1 to 0, we're going down in numbers, we're going down 1. But if we go from 0 to 1, we're going up. We continue to go back up. So we've changed directions, which means that it's going to be a quadratic. Now, if you look at 26, from left to right, if I look from left to right, as I go from left to right, it's increasing, so this is going to be growth. The only thing that has growth or decay is exponential. So if we look at this, this is a straight line. Well, straight lines are linear, so this is going to be neither. Okay, and then for exponential here, as we go from left to right, we are decreasing, so this is going to be decay. For 29, okay, we're going to be now combining like terms. So because there's addition here, all I'm doing is adding all the like terms together. So I'm going to write them together. So I have n to the 4th. I have another n to the 4th, so I'm going to write that, so minus n to the 4th. Then I'm going to move down. Okay, my next highest is just a minus 2n, just an n. Then I have a plus 5n. Then I just have my numbers left, so minus n, then plus 5. This kind of helps me keep organized, you don't have to rewrite them. Okay, so n, 1n to the 4th minus 1n to the 4th is 0, so those cancel out. Then I have a negative 2n plus 5n gives me a positive 3n, and a negative 1 plus 5 gives me a plus 4. So there's my answer. For 30, okay, it would be the same thing, but now I gotta change this minus to a plus and change all the signs after it. Oops. So I again write them together. So 8y to the 3rd minus 6y to the 3rd. Then I move to my y, so I have a minus y, a minus 3y, and I have a plus 7 and a plus 3. So when I go combine, 8y minus 6 is 2y to the 3rd. A minus y minus 1 and a minus 3 give me minus 4y. And a 7 plus a 3 gives me plus 2. Okay, for 31. This one I have to be multiplying. Okay, you can use your box. So 5 n to the 3rd times n to the 6. So 5n cubed times n gives me 5n now to the 4th. They add one more. And 5n 3 to 6 gives me a positive 30n cubed. So there's my answer there. For 32, the first thing I have to do is distribute this 3 to both terms. So I have 3 times 4x squared is 12x squared. And 3 times negative 5 is negative 15. Then I move and I say, okay, now I gotta distribute this 4. So now I have 4x squared, and 4 and 6 make a positive 24. And then from here, I'm going to my like terms. Again, I like to write them by each other, so 12x squared plus 4x squared, and a minus 15, and a plus 24. So when I do this, I get 16x squared, and I get a plus 9. Lastly, for this one, I think the best thing to do is to use your box. Again, now with this, and really with all of these, with your answer choices, you can graph and match. It basically works for most things. So 5y and 3y make 15y squared. 5y and 8 make 40y. 6 and 3y make 18y. And 6 and 8 make 48. I combine my those diagonals, so I have 15y squared plus 58y plus 48 as that answer. Okay. Okay, 34. So with this, again, perimeter, you gotta know what that means. So we're going to be adding all of our sides together. So we're gonna add the first side, so 2x plus 6. We're gonna add it to our second side, so a positive 6x minus 12. And add it to our last side, which is a minus x plus 7. And that's going to equal, because is means equal, 50. Now with this, we don't have to really solve this. Okay, combine in terms of really doing it. We're solving for what x is, so we go to our calculator, go to menu 32, change that to the 1, and we input it in exactly as it is. So 2x plus 6 plus 6x minus 12 minus x plus 7 equal sign 50, push enter, and voila. It is our answer. So x is equal to 7. With this, the area, so multiply. With this one, I really would say that we know that we're multiplying, so multiply your 2. Link them right together. And now we're graph and match. Okay, we really haven't gone over too much about how to multiply a binomial with a trinomial. And so I would go over and just graph and match and see which one's the exact same. Okay? So moving on to the next page. So for 36, it's asking what is the area of a triangle. We need to know that the triangle is 1/2 base times height. So 1/2 times our base, which is x plus 4, times our height, which is x. Now I think the best option is to start off multiplying these together. Okay, you can do a box, you can just distribute this x to both terms. When we do that, you get 1/2 x squared plus 4x. Now that we have that, now we're going to take this 1/2 and we're going to distribute it. So we have 1/2 x squared, and 1/2 times 4 is just 2x. So there's your area. For 37 through 40, I'm not really going to work these out. The real reason for this is I'll explain how to do it in the calculator. Oh my goodness. But past that, I just kind of feel as though the best way to do is just to graph and match, and I feel like I'm kind of wasting time going over past that. So with these, okay, remember that we go menu 331, and then for our answer choices, we do menu 32. Okay, that means let's say our answer choices were x. They're asking for one of our factors, and they say x plus 6, and they say x plus 3. Okay, so if we go to our calculator, the first thing that we're going to go to is menu 331. Okay, this is to find our zeros of a quadratic. So to type in our values, our a is before our x squared, which there's nothing there, so it's a 1. Okay, our b is in front of the x, which is 3. And our c, our last one, is the constant number, which is just a negative 18. And it tells us that our zeros are negative 6 and 3. Now, we need to know the opposite of what we're looking for. Or we can go, okay, menu for our answers, menu 32. We're only solving for one variable, and we're going to input a in by itself. So x plus 6, but remember we have to set it equal to 0. And it says that x equals negative 6. So that's one of my zeros, but let's just check ourselves. So then we have, okay, menu 32. Change that to 1, and now we type in b, which is x plus 3. Again, always setting it equal to 0, and we get that that's negative 3. So our answer here would have been this first choice. Okay, that's a good way to kind of be able to solve that. Again, Not going to really waste time on 43. Graph and match. They're asking which one is the same. Okay, same meaning equivalent. Okay, we know to just graph and match those. Same thing for 44. Okay, it's asking which expression represents. Same thing is the same. Same thing as equivalent. And we know when we see this word, all we do is graph and match. Okay, now we see. And that's another thing. Okay, please, please, please. For the 37 through 42, if you want to see those answers, you can look on Canvas and find the actual key to this. Okay, now moving on to the next page. For 45. Okay, 45, we done one just like this. Okay, again, this one's a little bit different, only the fact of the matter is x squared. Okay, so we're going to go through this. Remember, perimeter means we're adding. So we're going to add all these sides together. So 2x squared plus 6 plus 2x squared plus 6 plus 6x plus 13. And it's saying that it is, which means equals 4x squared plus 43. Okay, now, the first thing that we have to do with this is we are going to have to combine my terms. So I have a 2x squared, which is 4x squared. I have just a 1x, so just plus 6x. And then I have 6, 6, and 13, which gives me a positive 25. And it still equals that 4x squared plus 43. Okay, I haven't changed that. Now I'm going to start to combine my terms, okay, and start moving from one side of the equal sign to the other. Now when I do that, remember I have to switch my sign. So if I have 4x squared and now I'm going to move that to the left, I'm going to have to subtract 4x squared to both sides. Now, when I do this, 4x squared minus 4x squared is 0, so they cancel out on both sides. So I'm left with 6x plus 25 equals 43. Now, with this, I can put this now into menu 32 and solve for x. So in my calculator, I can go menu 32, change that to a 1 because I only have one equation, and I can type in 6x plus 25 equals sign 43. And it tells me that x is equal to 30. Okay. So 46 is just asking how do they compare? Okay, now to do this, easiest thing is just actually just drop it. So when I open up a new document, and I'm going to graph x squared plus 2, and then I'm going to graph on the same thing, so tab x squared minus 1. Now what happened? Well, it moved down. So it shifted down, or how does the blue, how did that translate from the red? Well, it shifted up. Okay, same thing 47, how does the graph of y equals negative 4x squared? So I'm going to go now to, again, a new graph. And I'm going to go to negative 4x squared and graph it. And then I'm going to graph 4x squared. Well, how did it change? It is reflected. Okay. 48. If the graph of the function y equals x squared minus 3 is moved up 4 spaces, what is the new equation? So all I gotta do is add 4. So negative 3 plus 4 is just a positive 1, so my new equation is y equals x squared plus 1. Okay. What are the x-intercepts of the parabola? So with this, I can decide I want to graph it. I can decide I want to go and do menu 331. If I graph it, open up a new graph and graph x squared plus 4x. Okay, from there I can go and I can find my x-intercepts. Now to do this, I know menu 6, 1, which is 0. Anywhere to the left or right, click, start to scroll. I see one of my zeros is -4, and as I continue to scroll, I see the other one is 0, 0. So I have -4, 0, and 0, 0. Okay, asking for the solutions. So remembering that solutions are the same thing as your x-intercept, same thing as your zeros. Now with this, remembering I have to move everything to one side. So I gotta move this 5x over. When I do that, it becomes a -5x. So I would graph it. So x squared minus 5x minus 5x minus 6. And again, menu 6, 1, 5 zeros, anywhere to the left or right. Start to scroll, I see 6, 0, and -1, 0. So 6, 0, -1, 0. For number 51, which of the following is a parent function? If it is a parent function, it needs to go through the origin, which is 0, 0. So 0, 0 is right here. Which one is touching that? Is A. Okay, find the solution. Again, with this, I'll do this the other way. So instead of graphing this one, I'll go through and I will calculate it. So menu 331 because it is a quadratic. And I type in the x squared coefficient is a 1, the x is a 3, just the number is a 2. And it tells me my solutions are -2 and -1. Okay, next page. So for 53, with this, the best thing to do with A is to graph it. So when we graph it, we have -x squared minus 3x minus 2. And so we're going to have to find the vertex, the axis symmetry, the max isn't a maximum, a minimum, and the y-intercept. Okay, y-intercept's easy. Okay, we love 1, so -2, so 0, -2. Maximum minimum is the curve at the top or the bottom. It's at the top. So if you're at the top of something, you're at the maximum of it. Okay, so now our vertex would be our next hope. So if we go to menu 6, analyze our graph, and we want to know what is the maximum point, so 3. Anywhere to left or right. And we see that it is -1.5, 0.25. Now, axis symmetry, we don't have to do anything else because we know that our axis symmetry is just the x value of our vertex, which is x equals -1.5. So with B, it's already graphed for us. So for B, our y-intercept right here, 0, 0, is the maximum minimum. It's at the bottom, so it's a minimum. Our axis of symmetry, what is our vertex first? So our vertex here is 3, -9. Oops. So then we see that our axis will be x equals 3. Okay, for 54. Well, 54 through 60. We are going to look, is it linear, quadratic, or exponential? So linear is just going to be, so it's going to have an x in it, just an x. It can also be a straight line, so horizontal or vertical line. So all those are x equals a number or y equals a number. For quadratic, it's going to include x squared, and for exponential, it's going to be to the power of x. Okay, so 454, when we look at it, it has an x squared, so we know it's quadratic. And then we can go to our calculator, and if we go to -331 to find its solutions. Whoops, not what I wanted. Menu 331. Then we type in 5x squared, so 5, -3, and 7. We get an empty box, which means that it has no solution. For 55, we see it's to the x power, so we know it's exponential. Exponential functions are never going to touch the x-axis. There's an asymptote there. So for exponential, it'll always be no solution. It's asking for a 0. For 56, it only has that x, so it's going to be linear. With this, doesn't necessarily matter if we wanted to graph this one, just to kind of change it up a little bit. We would graph our 2x plus 6, and we see where to touch the x-axis. It touches it at -3. So it would be -3, 0. And then if we look at 60, it's just that y equals a number, which is going to give you a horizontal line at y equals 5. So it's linear, and there would be no solution. For 61, so understanding and kind of remembering, so exponential functions are going to look like this. So if we look at this, kind of follows that model, so this is exponential. For quadratic, it's going to have either a u or an n. We look here, it kind of makes a u, so this would be quadratic. And linear is going to be any type of straight line that's given. Okay, so if we look at this is a straight line, so this would be linear. Okay, moving on, 64. So looking at domain and range, now for this one it has 2 endpoints, so we're going to have 2 points in our inequality. So we have our x is our domain, so our least value is 1, our highest value is 8. For range, again, what are those endpoints at? And we go from least to greatest, so 2, our signs are always the same, and 6. For 65, these arrows show it's going to continue to go on in the direction it's going. So those arrows on both sides, remembering that our domain is always all our numbers. And then our range for exponential, remember it can never cross this line right here. It can never touch it, it can never cross it. So y is always going to be greater than 0. That will never change. Okay? Now, for 66, looking at this, for any exponential that we deal with, our range is going to be all our numbers. So for both of these, it will be all our numbers. Now from this, the best thing to do is going to be to graph it. So for these range, we're going to graph it. So we go to a new table. A new graph. Sorry, it's the one thing. Okay. New graph. So we're going to graph, so negative x squared plus 3x minus 4. Okay, and when it graphs it, we're looking for our range. Now, if we look at our y, if we look at how our graph is, the graph is going down, okay, which means that all of our y values are going to be less than that max number. So we're going to go and we're going to find our maximum. And whatever that y value maximum, we know our y is going to be less than that. So we know our y is going to be less than or equal to that y value, which is negative 1.76. 1.75. Okay, same thing for 67. When I graph this, I'm going to graph 3x squared minus 9x plus 6. Now, we see on this one that our y values are going to be everything above this minimum point right here. So when we go to menu 6, we're going to go to our minimum point, which is 2. And again, we're looking, what is that y minimum point, which is negative 0.75. So now y is going to be greater than or equal to that minimum point, which is negative 0.75. For 68, 69, I'm going to do one of these. So I'll just go ahead, do the same thing. I'll do the 68. So we need y equals. So we're going to move this 5. And we're going to add it to both sides. Okay. Now again, it has this squared right here. So we know if it has a square, it's quadratic. And now we're looking at transformations. Okay. If there is a negative, it's going to be a reflection. Now, the negative has nothing to do with the number that it is attached to. So then I look at the number next. It's a 2. Okay, I'm not looking at negative, I'm not looking at positive, I'm just looking at it is a 2. Okay, 2 is greater than 1, so it's a stretch. Then I look in here. Okay, remember parentheses y. So x plus 3 is really going to be, it's going to shift left 3. And then at the very end, I have that plus 5, which is up or down, and so it's going to be going up, up. Okay, for 70, you can skip this. It's all you do is put this in your calculator, find your table, and graph it. Okay, there's really nothing much to it. Now for these, for 71. Okay, the best thing to do is just kind of write it out into expanded form. So underneath I have 4 x's, I have 2 y's, and I have a z. So we're going to go and we're going to make pairs. So I have a pair, four y's, and that's it. So remember, I just take out what the pair is made out of. So I have a pair of an x, I have another x, I have a y. And then underneath, I'm going to still have a z. Well, I have 2 x's outside, so I have x squared y square root z. Okay, for 72, I have to factor 36. If I don't know what the factors of 36 are, in my calculator, I can go just to a calculator. And I can go menu 2 number 3 factor, and just type in the number itself, so just 36. And it says it's 2 squared times 3 squared. So that means I'm writing 2 twice, and I'm writing 3 twice. Then I have 11 x's. So 1, 2, 3, 4, 5, 6. I have 6 y's. 1, 2, 3, 4, 5, 6, and I have 9 z's. 2, 3, 4, 5, 6, 7, 8, 9. Okay. Again, I'm looking for pairs. So I have a pair of 2, I have a pair of 3, and my long simple pairs. Okay. So I pull out what I have. So I have a 2 and a 3 that are coming out, which makes 6. And I have 1, 2, 3, 4. Oh, I didn't do that. 5 x's. 1, 2, 3 y's. And 1, 2, 3, 4 z's. And then left underneath, my line goes out. I have an x and I have a z. That's all I have left. Okay. And then for 73 again, I need another factors of 54. So menu 2, 3, and type in 54. And I get 2 times 3 to the third power. So I leave what I have outside. So I keep my 3. I'm going to keep my 3. That's y on the outside. I don't think I'm going to write it expanded. What was it? It was 2. Oops. 2 times 3 times 3 times 3. Then I have 5 x's, 1, 2, 3, 4, 5, 2 y's, and 1, 2, 3, 4, 5, 6, 7 z's. Okay, again, I have to go on conjugate. Now the only thing with this one is now I also have the numbers outside. So I have a pair of 3s, I have x's, y, z, z. So I'm going to plot a 3 outside. Well, now I have 3 times 3, which is 9. I have 2 x's, but now I have another x, so I have 3 x's. I have 1 y, I had 1 out already, so now I have 2. And I have 1, 2, 3. No other z's, so just 3 z's. Now underneath, I have a 2 and a 3 left, so 2 times 3 is 6. I have an x left and a z left. And there's that answer. Now, I'll do 74. But all this is finding solutions. All you have to do, well, I'm not doing 74. I'll do 77. Okay. Even same thing applies to 76. I have to make sure it's equal to 0. So I gotta move this 4 over to the other side. So I have x squared minus 14x plus 4 equals 0. Now that it's equal to 0, once it's equal to 0, I just go negative 3, 3, 1. And easily it's going to be my answer. So the value in front of x squared is 1. The value in front of x is negative 14. And the value in front, or by itself, is 40. Push enter and I get that x equals 4 and x equals 10. Okay? So that's how you do those 4. Now last page. So an amusement park charges an admission fee of $5 plus 75 cents per ride ticket, which equation best represents C. The total cost for a person to ride the amusement park to purchase are tickets. Well, per ticket is 75 cents. Is per ride ticket. And then there's an admission fee, which is $5. And all of that is going to equal how much they have to cost. Okay? So if I find that, it may be written a little bit different or a different little order, or probably, sorry. And so we see C is our answer. For 79, which monomial represents the area? Okay, remember area, we have to know what does that mean? That means I'm multiplying. So I'm going to multiply 3, a squared b, c3, and 5, a, b, 2, c4. Now, mathematically, I'll rewrite it 3 times 5, A2 and A, B and B2, and C3 and C4. Now, 3 and 5 give me 15, A2 and A give me A3, B and B2 give me B3, and C3 and C4 give me C7. Again, if I wanted to do this by graphing and matching, when I had my 3a squared bc and my 5ab 2c4, if I wanted to graph and match, just kind of remembering, I have to get rid of b and c, I have to get rid of b and c, and so I have to get rid of b and c in all of these as well. Okay. For 80, so Yummy Bakery sells apple and blueberry pies each Saturday. Apple pie costs $8. Blueberry pie cost $12. Last Saturday, the bakery sold 4 more apple pies than blueberry pies for total sales of $232. So, okay, we know that apple pie is $8, so 8A plus 12 blueberry is going to be equal to 232. Now, all of them say that. All the answers say that. So then we gotta look at our next equation, which should be a little tricky because it says 4 more apple pies than blueberry pies. Okay. So your apple pies is going to be 4 more than your blueberry pies. And so with that, your answer is B. Last one, 81. For this one, they want to know what x is, okay, but they give you what y is, and they give you an equation. So all you have to do for this is 4x equals 5, y, all I'm going to do is I'm going to plug in my y value. Okay, all I do is plug my y value in they gave me, enter y. Now, once I do that, easy. Menu 3, 2, whoops, menu 3, 2. We just have one equation. We're solving for that x, and we have our equation. So 4x equals sign 5 parentheses negative 3.2 minus 17. And we get negative 8.25, which is J. Okay, not all of them I worked out. The key also is on Canvas, so you can go through and you can check your answers on there. Okay, if you have any emails, you can try to email me. I will try to get back with you as soon as I can, especially if you're in my 7th period. I'll try to get back with you by Monday, since your final exam is on Monday. But I will get back to you for your exam dates. Okay, good luck.